Okay, so today we're going to be talking about piecewise functions, but to know about piecewise functions, you need to know what each one type is. So we've got a linear type function. This is his standard form, y equals mx plus b, where m is the slope and b is the y-intercept. However, what I've drawn for you is the parent function, where y equals x. That means that we don't have, or we cross the y-axis at 0, and our slope is up 1 over 1, up 1 over 1. There's also the exponential function. This guy has a growth if his rate is bigger than 1, or a decay if his rate is less than 1. This is the y-intercept, and this guy is the rate. So what I've graphed for you is a 1 as the y-intercept and 1.5 as the rate. That means he grows by 1/5 every time. Okay, we've got also the quadratic form. Here's our quadratic form, where h shifts us left and right, and k will shift us up and down. And then the parent function that I've graphed for you is y equals x squared, which means that my vertex is at 0, 0. We also have a square root form, which is kind of a sideways parabola. You can see maybe where a, again, just makes him wider or skinnier or flips him. H will shift him left and right, and k will shift him up or down. What I've graphed for you is the parent function, y equals the square root of x. That means that we start at 0 and we will grow from there. Okay, here's the absolute value parent function. He's a V shape, but again, we have that A, that's what's going to make us wider or skinnier. The H will shift us left or right, and the K will move us up or down. This is the parent function that I've graphed for you, meaning I started at 0 and I'm moving over 1, up 1, over 1, up 1. And then last, we have the cube root and the cubic parent function. So the cube root is a sideways S. His parent function, the inflection will be here at 0, 0. But if I'm going to shift him left or right, that H will tell me how much, and that K will tell me how much right, up or down. And the A makes him wider or skinnier or flips him. And then the cube function kind of looks like this, just turned, bloop, because they're inverses. So he looks like an S, but with one arm down and one arm up. Again, the H will shift us left or right. The K will shift us up or down. This makes him skinnier or fatter, or if it's negative, it will flip him. But what I've graphed for you is the parent function. All right. So if you don't have those in your notes, you can go ahead and get them. But what I'm going to require of you is that you can give me the equation for each of these graphs. So this right here is a cube function. This is his standard form. Usually, this will go do, 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 and cross through 0 and go do, 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 do. But that's not what happened. He's actually crossing here at -1. So our graph is going to be this. H, and because he went to the left, we're going to +1 squared, but he didn't move up or down, so you could put +0, or just y equals parentheses x plus 1 cubed. You could do that too. All right, this particular fellow, he is the absolute value, so I've given you the standard form. Now, he did not go over 1, up 1, over 1, up 1. He went over 1, up 2, over 1, up 2. So we're going to write this as either 2 over 1 or just 2, absolute value of x. And then instead of being at 0, 0, he moved himself to the right 3. Remember, inside is exactly opposite of what you think, and then down 2. So that will give us that particular fellow. This one I gave you the standard form. Remember, A is where we cross the y-axis. In this case, it's 1. But to get from here to here, I went up 1. And then to get from here to here, I went up 2. From here to here, I went up 4. So what's happening each time? Well, we're doubling. So our rate is 2 to the power of x. Now, last is our line. These are probably the most familiar. You know that B is my y-intercept. We cross here at 1, 2, 3. But the slope takes me down 1 over 1, down 1 over 1. You can see that? So we're going to write it like this, down 1 over 1x. If you write it as y equals negative 1x plus 3, that is perfectly acceptable. But what's going to happen with Piecewise is they'll give you a graph, but only part of it, not the whole thing. So here's where we're going to start with our nodes. What I like to do first is establish that I'm going to talk about one graph and then a second one after I've finished the first, and then the last one. Okay. So let's start with just this first one. This first one, the type of graph is linear, which means this is our form, y equals mx plus b. To get that equation, what I need to know is where do we cross the y-axis? So I'm just going to extend that. Oh, it crosses at negative 2. And then the slope, do I go up and over for this one to keep this line or down? No. So we don't have a slope. That means that my equation is going to be y equals negative 2. That just is a straight kind of a guy. But I do notice that I have this arrow going to the left forever. And if I'm talking about x's, it stops, this line stops right here. Now this is at 0 and this is at negative 5, so I'll put negative 5. And because he's a closed circle, I'll put less than or equal to negative 5. Okay, the next one, this fellow right here, he's an exponential growth. So I'm going to put exponential. And the standard form for this guy is this. Remember, A is where I cross the y-axis. So this happens, there's 1, 2, 3, 4, 5. That's going to cross at 2. It's kind of hard to read my graph here, I see. But to get from here to here, I moved up 1. And to get from here to here, I moved up 2. And from here to here, I moved up 4. So what's happening each time? Oh, I'm doubling. So that's my rate. Now we don't have the whole exponential graph. He doesn't go forever. In fact, he only gets started right here at negative 5, but it doesn't include negative 5, an open circle. So we leave him as just the less than. And then he keeps going right up until this spot right here, which happens to be 1, 2, 3 on my x-axis. And that's also an open circle, so I'll leave him like that. And then last, you can see I have an absolute value. His standard form is y equals a absolute value of x minus h plus k. So our equation, y equals, see, he's going over 1, up 1, over 1, up 1. So I could put a 1 there of x. Usually absolute value starts at 0, 0. Well, this one shifted all the way here to 6. So we're going to put minus 6. And then he went down 1 spot. So we'll put a minus 1. And that means that our range, or the domain, the groups that we're looking at, start here at positive 3. And that's an open circle. All the way to, oh, that's infinity. So we'll go to the infinity on the right. That's positive infinity. So as you go through these, what I want to see is that you can recognize what type of graph it's going to be, set up the equation, and then give me the range of what we're talking about. In fact, on the x-axis, from where to where is that happening? Okay, same with this one. So this one, you'll notice that the first one is a linear fella. And what I'd have to do is keep extending this, extend, extend, extend. Sometimes it helps to have a straight line maker. So I'll use the edge of my paper here so I don't make a mistake. There he is. Okay, so if I extend this, you see I cross here at -1. So in my first group, I know I have a linear form, who is y equals mx plus b. Well, it was important to know where he crossed the y-axis, which was at -1. So that's why I extended this out. But the slope itself, we're going to go up 1 and over 1, up 1 and over 1. So I've got y equals 1x minus 1, or you could put 1 over 1. That would work too. The range, though, see, this tells me I'm on the left forever. And I keep going until here, which is my -5. All right, so you can use your straight line makers to help extend what you're doing. Here's my next group. Well, now this is an absolute value graph, which is y equals a absolute value of x minus h plus k. Well, the h and the k tell me that I've shifted from the origin, which I haven't. So this is just my parent function, actually, because he goes over 1, up 1, over 1, up 1, and he starts at 0, 0. The range, though, starts here at -5, less than or equal to, because see that that's filled in, and he keeps going until here, which is at +4. Whoops, I need an x. I need a +4. There we go. So then let's look at this last one, C. This is also linear. Which means I need to know where that y-intercept is. So I've got to extend my line, like my fancy line maker. You could use a ruler. But if I extend this out, you'll see I cross, here's 1, here's 2, here's 3. I cross the y-axis at 3, at +3. And this guy also just goes up 1 over 1, up 1 over 1. So you can use it like that if you'd like. Or if you just write it as y equals x plus 3, that is the same thing. Well, this particular line doesn't start until 4. It's an open circle. So less than x, less than, and the arrow tells me we're going to go to the right forever and ever. So as we work with piecewise, we're just taking these graphs and finding those pieces and then making sense of them.